general form here. So any equation which takes this form of ax squared plus bx plus c, where a, b, and c are just integers, and x is an unknown. Any equation which takes this form is immediately known as a quadratic equation. And what that effectively means is that any equation where we see an x squared, or x to the power of 2, makes it a quadratic equation. So we can have, as we see on the top right here, an example of x squared plus 3x minus 4 equals 0. So we see the x squared here, and that means that a equals 1. The a and b are coefficients. So a equals 1, b equals positive 3, and c equals negative 4 in this case, in this equation here. The reason why quadratic equations are even called quadratic equations is because it comes from the Latin word quadrus, which means a square. So again, it's just anything with an x squared. Now, this does look a little bit scary, but we can see that they are actually not as difficult to crack as they look. So don't be intimidated by the presence of this x squared. Now, the reason why they're a bit tricky to solve is because you can't simply rearrange the equation like you would with a linear equation. So if we were to, for example, ignore the x squared, we would just put 4 onto the other side of the equation, divide by 3, and suddenly we'd have 1.3 recurring as being x. But we can't do that here because if we divide by x, we simply get a term of something over x and x. So we don't really help ourselves there. So this requires a slightly different approach. And as this is our first encounter with a quadratic equation, we're going to have to revert back to the simplest and most tested way of doing it, which is called solving by inspection, which simply means plugging numbers in and seeing if it does satisfy the equation. Because remember, all this equal sign means is that the right-hand side, 0, is equal to everything here on the left-hand side. So let's get started by trying 0 as our value for x. Now, 0 squared equals 0. 3 times 0 is also 0. So we just have minus 4 on the left-hand side equals 0. So that's incorrect. So 0 is not a solution of this equation. Let's move on to 1. 1 squared is 1 plus 3. So we have 4 minus 4 equals 0. So here we have a solution of the equation. X equals 1 is a valid solution to this equation. So fantastic. So we've kind of already partly solved the equation, but as you'll see, there's some more steps to do. So we want to factorize this equation to essentially reverse the expansion of brackets. So when we have now figured out that we have a solution of x equals 1, we can now take out this bracket of the left-hand side of the equation. And because we know it's a valid solution, because it satisfies the equation, we can therefore say that x minus 1 brackets, followed by a second set of brackets of the other factors of that equation equals 0. And we know this is true. We can prove it to ourselves because when we take x equals 1 as the solution, which we already know works, if we put in x equals 1, this bracket goes to 0. 1 minus 1 multiplied by whatever else, it doesn't matter, because this is 0, equals 0. So there we go. We've checked that this is true. So this approach is basically now trying to get back to the original equation, x squared plus 3x minus 4. So what do we need when we expand these two brackets to eventually get the top equation here? Well, first of all, we can immediately say that we're going to need another x, since x multiplied by something must give x squared. So x multiplied by x, when we expand this bracket out, there must be an x there. That is a fact. And when we put that in, therefore, and say x minus 1 brackets x dot dot dot, we've already solved the second half of this second bracket. So this is already a great step. Now, this is to find the x squared. However, we also need to we also need to be able to produce -4. And therefore, the second half here, -1 multiplied by something, must give -4. And the answer to that, of course, is +4. So now we have a fully factorized equation. Just by inspecting the original equation and just seeing that x equals 1 is indeed a solution. So we can now rearrange this equation and simply say, okay, well, if we divide by brackets x minus 1, this disappears, and then we have x plus 4 equals 0, so clearly x equals -4 as well. So x equals 1 and -4. So this is a very important point that quadratic equations need two solutions. They always have two solutions. And that is because obviously when we have an x squared, if you take the square root of something, you also always get two solutions. So just by inspecting the first equation, finding a solution, taking out that bracket, and then building back up to see if we can expand those brackets to get the original equation, we have correctly solved this equation. So that's great. And with the student, I would then go on to looking at these equations graphically and demonstrating how a quadratic equation intersects the x-axis twice. I would then go through other methods of completing the square, for example, and build up a more complete picture of the equation instead of this more practical way to solve this particular equation.